This interview was forbidden. We hid inside of the Computex Convention Center past closing at the late hour of 6:01 p.m. to conduct one last technical interview with Noctua about the engineering of its fans. We needed silence for the discussion, and this was the only way. But we had everything going against us. They killed the lights while we were filming for them, but are they... We've got our own lights. Thank you very much.
Let's keep going.
We'll stand a little closer. They blasted annoying music for half of our shoot.
Starting point would be the development.
And then they sent security to come find us.
Yeah, we had to go back to the...
Fortunately, although the guards didn't speak English... Let me tell him really quick. 不好意思，需要大概10个分钟，可以吗? They must have really appreciated the engineering details on the fans because they let us finish the shoot. This is Jakob, and he's going to be speaking about engineering challenges and Noctua's focus on manufacturing something function and performance-focused in an industry currently forsaking performance as it gets ever more entranced by RGB LEDs. It's just enough education and chaos to make for an excellent video, so let's get started. Before that, this video is brought to you by Squarespace. We use Squarespace for our own GN store and juggle complex, multi-piece orders all the time with it. Squarespace makes it fast for us to roll out new products with detailed pages full of galleries, videos, and descriptors. It's also useful for your own resume sites, for photographer or project portfolios, or for starting your new small business idea. There's never been a better time to try and start your new business than right now, and we can vouch that Squarespace makes it easy. Visit squarespace.com/gamersnexus to get 10% off your first purchase with Squarespace. Hey everyone, so we're at the Noctua booth. This is a really unique opportunity. I'm going to be joined by Jakob, who actually you've joined in the past, even if briefly, to receive an award for least RGB bullshit at a show. It was actually 2 years running that Noctua received that award. But Jakob's going to be joining to talk about fan development lifecycle, designs, prototyping, and a lot of technical information.
Yes.
So it'll be really fun.
Well, Steve has covered our roadmap updates quite frequently in the past. So if you're familiar with that, you've seen that we had to delay our next gen 140mm fan again and again. So we thought we'd take Computex this year as an opportunity to explain a little bit why this has been the case and what has made it so challenging to get this fan ready.
And so that's why this video came about, because originally, normally the way this works is I go to the booth, I collect information, I take notes, and then I host a video and talk about it. When Jakob started talking me through all of this and 8 years of development, I said, let's just talk about this on camera because it's getting complicated. So it is a good opportunity, I think, to talk about. Noctua, I think, famously takes its time to and also brands itself on quality. But it does make sense to take the time to explain more about why. So wherever you want to start, open discussion, open game. So.
Absolutely. So I think the first starting point would be the development phase. Whenever we start fan development, we set a goal, performance benchmarks we want to reach. So in this case, it was firstly our existing NFA14 fan, and secondly, our NFA12X25 fan that performs extremely well when you put it on radiators using our 120 to 140mm adapter. So in this case, we were in a situation where we had to improve on existing fan designs that are already highly optimized. So whenever we are in this kind of situation, creating an aerodynamic design that provides a meaningful improvement is a very challenging endeavor. And you shouldn't think of the process that starts at this point as a more or less linear development where we just keep tuning one design until we're there, but it's usually iterative cycles where we have to go back to the drawing board when we realize that a particular design approach doesn't give us the results we want to. And in the case of the new 140mm fan, this actually happened several times. So with the impeller samples you can see on display here in the back, we have several cases where we actually didn't meet the performance targets we set out. And one case, that's the 2016 one, where we actually ran into a situation where we had quite satisfying performance, but found out that the design was actually not feasible for mass production. So this is another brick wall that we can hit within the development phase.
It is easy to look at all the companies pushing new fans every year and go, where's Noctua? And the answer that Noctua has given is researching and developing, right? That's where Noctua is. And it makes sense because one of the things we were talking about was the concept of a fan that is as tuned as possible for the best performance in multiple scenarios. So like honeycomb mesh, a radiator like this, a radiator like maybe a water cooling radiator, as opposed to a fan that a manufacturer might make only for, say, one scenario.
Yes, definitely. When we come out with a new fan design, we always want to make extra sure that it really ticks all the boxes and that there's, even if it's a sort of niche application, like a very particular fan grill type, that we don't see any really problematic results in these. So whenever we go to the engineering validation tests, these need to be run on a wide range of applications, from different heat sinks, different radiators, to different types of fan grills, both in push and pull applications, until we're really satisfied with the design.
So what kinds of, when you're going through the design and development, I guess if we can walk through this, when you go from simulation to, say, prototyping, I would assume, I mean, do you move on from simulation at that point, or are you still simulating for that design even after you've made the prototype?
I would say both. Simulation is always the first starting point. When we have the basic design approach, we start with simulation to see where we are likely to end up. And then if we're happy with the simulation results, we will go into prototyping. But the test data we get from the prototypes is actually something that's fed back into the next round of simulations, which again informs the next round of prototypes. Right. This is what I was referring to as iterative cycles that really go on enhancing, fine-tuning a particular design until we reach the desired outcome.
Simulation, in a perfect world, you run your CFD simulation, and there you go, there's your fan, you're done. What types of things, when you're doing the prototyping, perform differently than simulation might expect, or what might prototyping inform that simulation cannot inform?
Yeah, I mean, I would say generally simulation works really well for example, getting a better idea about the load profile at different parts of the fan blade. So generally you want to have as even blade loading across the entire blade span as possible, and not, for example, the area close to the hub doing nothing and the outer parts being overstressed, so to say, as far as loading is concerned. This is something that can be done very well in simulation. Where simulations start to struggle is aspects like blade-to-blade interaction, so one blade following the other, and the wake flow of the first blade affecting the other, because this is starting to get quite complicated. And also aspects like interaction between the blades and obstacles like radiators or heatsink fins, but also especially fan grills. The fan is pulling air through because the turbulences that occur in these cases are very complex and tricky to simulate.
Okay, so these are, just to get everyone on the same page, and I'm going to apologize for the music in the video. We didn't add that in post, just so everyone knows. I'm sitting here listening to it, I'm like, people are going to say, please don't add music to these videos. That's just what it sounds like here.
It's also not music we're playing here at the booth. It's just everyone get out music of Computex.
We are past closing time. So these, to get everyone on the same page, these are all the same fan ultimately. They all led to the same fan, I should say.
They all led to the same, but as you can
different.
See, they look actually look very, very different.
Was this the final?
This is, yes.
This is the final.
Yes. So when you look at the different prototypes, you can clearly see why I stressed that it's not a linear progression of one design, but actually different design approaches that are being optimized in these iterative feedback cycles. You can see, for example, that the 2015 sample has very wide blades versus the 2016 sample being more close in design to our existing A12X25 fan. The 2017 sample, for example, has 10 blades versus all the others having 9.
Just by looks is almost wildly different. I mean,
it is.
Very different.
It is a completely different approach that we took after the 2016 design, actually meeting our performance benchmarks, but turning up being not suitable for mass production. So we took a completely different and very unusual turn in going for a 10-blade impeller, which is something you would not normally dare to do, because pairing a 10-blade impeller with a four strut frame means that that the number of there's a common divider between the two numbers, which is very challenging acoustically. We were hoping that we could get it work, and with the template design, we actually have a slightly larger blade coverage.
So does that produce like? Is it an undesirable whirring or buzzing?
Due to harmonics of the blade passing frequency, so you get multiple harmonics. So in the frequency spectrum, you would see typically more prominent spikes in multiplying the blade passing frequency.
I see. Okay, so clearly Noctua knew that common divider problem going into it.
Yes.
Decided to try it anyway.
Yes, because we were stuck with the previous design, and we expected major performance boosts on the radiator, but in the end, the acoustic penalties outweighed the performance boosts we saw.
Well,
in
that's
high
good
pressure applications.
Good that Nox was actually testing for this and cares about it.
Well, that's our job, I guess.
Yeah. Well, yeah, not everyone does that, but. Yeah. Okay.
So in the end, yes, it took 3 more different approaches until 2020. We finally ended up with this is basically the very first 3D printed prototype of what ended up being the hopefully, knock on wood, final design.
Right.
At least it's definitely the design that we decided to further pursue. So by October 20, we had to complete the motor design, of course, and the design for manufacturing validation. And then by October 2021, we finally proceeded to the tooling phase.
It is interesting to see this more pronounced hook develop in here as time went on. Top of your head, I mean, any top level explanation of why?
Yes, the reason is again blade loading concerns.
Okay.
Generally, the problem, or one of the key challenges with fan design, especially when the diameter goes bigger, is that you have the zones close to the hub rarely doing anything at all because the rotational speed is so slow, but the outer zones being highly efficient. So you need to make sure that you push as much air as you can possibly push outwards, but at the same time make sure that the inner region is efficient enough that you don't end up with leak flows at the hub region.
Okay.
So in a high back pressure situation where the fan would blow against the radiator, if the blade region near the hub is not properly designed, you would actually end up with airflow coming back near the hub of the fan.
Okay, I see.
And
that's interesting.
This is our design approach for how to avoid it. What we have to do next is figure out which material we want to use for mass production. This is largely informed with the test we still do in the engineering phase. You can see prototypes manufactured from different materials here. We did this with all of the designs you see here. The purpose being that using different materials in CNC milled prototypes gives us different clues of what to expect using different materials in injection molding. For example, regarding resonance, vibration, creep, tensile strength, stuff like that.
So can you, most of those I know, creep, can you define in the terms?
Creep, I mean, the crucial issue with creep is that if a fan runs for years and years, especially at elevated temperatures, it will grow. The impeller will grow due to the centrifugal forces pulling the mass outwards. And with our high performance fan designs like this, we started this with the A12. We go for an extremely tight tip clearance. In this case, it's 0.7 millimeters. And in this case, creep is a major factor because if the impeller would grow, let's say, by 0.6 over the years, you would be very, very close to serious trouble.
Right, yeah. And I've experienced that with, I won't throw them under the bus in this video, I guess, but I've done it before. Another brand's fans. We used 6 of theirs in one of our systems. And over a period of a couple of years, I would say 3 or 4, they all started clipping the inner wall of the frame.
Oh.
This was several years ago. This is like before the big LCP sort of fad. And I think in every single, it was basically almost 100% failure rate where this happened. The product did get discontinued. And my understanding of that was always that it was either the blades growing outward or some other issue with the frame housing itself.
Yeah.
But it sounds like that's the issue where it's just expanding. But it's not as simple as, well, just build it as close to the frame as you can then.
Yes, because of tolerance challenges.
Right.
We'll get to that in a second, because this has been the major obstacle with this development project. Basically, we figure out the material, we construct the injection mold, so this is figuring out the flow path, figuring out...
so we're in here.
The injection points. You need to account for the shrinkage and warp behavior of the materials you've chosen. So all that is done through extensive simulation, and then we construct the injection mold as such, and manufacturing that takes around 3 to 5 months. So it's a major time investment as well. Once the tool is manufactured, you still need to figure out the exact injection parameters. So we're talking about feed rate, so the pressure that is used to press the plastic into the injection mold, temperatures at different zones of the mold, and especially cool-off times, cool-off curves, how fast you want to cool off your material.
And these are all manufacturing decisions, I guess?
Yes,
at this point?
Yes. And then once you figure that out, we step to the prototype production. We produce around 20 to 50 units for the design validation tests. This is one of the most important tests, I would say, because we have to zoom in on all aspects of performance once again, as we've discussed in the engineering validation tests, acoustics, of course, electronics, because by that time motor design is finished. So we're talking about stuff like ESD, EMF, commutation, behavior, all that kind of stuff needs to be checked. Visuals last but not least. And the whole DVT test as such, just to give you an idea, usually takes 3 to 5 person engineering teams several weeks to complete.
Okay.
So it is a major undertaking.
So if things go relatively smoothly, what's kind of like start to finish for just this block, this tooling phase?
In this case, we only had to slightly fine-tune some of the injection molding parameters, and we managed to reach the final validation phase by June 2022. So I would say that was relatively smooth sailing. It would be hard to pull that off more quickly than that.
Right. Okay.
So now we come to all the tolerance issues we've already referred to. Sadly, it was in the final validation phase that we started to see problems with this fan. There are two key tests in this phase. One is the MVT, the manufacturing verification test, which is an accelerated long-term test that runs for 4 months, making sure that we don't have any problems with the impeller creep, for example, impellers not growing larger.
Right.
And the second being the long-term thermal creep evaluation, where we examine how the fan behaves under external stress. So that would be pressure from radiator mounts or pulling force from fan clips. And just to give you a rough idea of what a major undertaking this kind of test is, the MVT doesn't only just run 4 months, it also takes a lot of time to prepare and to analyze afterwards. Because we put 50 fans into this test, and we basically need to complete something like a full health check on the fans before they go in, and a full analysis after they come out. So that involves full performance testing, full electrical testing, full acoustic testing, and complete 3D scanning, so that we can exactly track the changes that have occurred during that 4-month testing period. And these results are then fed into simulations again, so that we can get a good idea of how the fan would look like after running for 15 years at 50 degrees or something like that.
Yeah, and this is why it becomes a challenge where if at any stage, I guess, you hit something where you go, no, this isn't quite perfect.
Yeah, it sets you back far. And each of the steps will have to be run through again. And that takes a lot of time.
I see. So what happens when you start hitting this final validation section?
Yeah, so in this case, we first had an issue with the MVT, where we realized that there was a minute tilt in the hub region of the frame. And due to the tolerances being so tight, this caused the blade tip clearance to fall underneath our specified limit. Because with a 140mm design, due to the larger size, just a very slight tilt will have more drastic consequences than with a smaller size.
It starts exaggerating the sort of rise over run as
And the root cause analysis we had to perform then actually took us several weeks, because the underlying issue was something we didn't expect at all. The water temperature of the cooling fluid for the injection mold was slightly lower than it should have been. And this resulted in a steeper cool-off curve, which in return left, due to the quicker cool-off, more stress inside the plastic. And this stress got released at the high temperature tests, long time tests, and caused this slight warp or deformation in the hub region, that caused again the
So at any
tolerance
one of
issue we
these
saw.
phases, did Noctua have I'm going to call it a good enough? Did Noctua have a good enough product where it could go, we're just going to ignore that problem and just make it, or because I know Noctua tries to tune for being the best, which is a good place to position the brand because a million people make all kinds of fans. I guess what I'm really curious about is when other companies run into these types of problems, and obviously you can't speak for them, but are they? We've got our own lights. Thank you very much.
Let's keep going.
Let's stand a little closer. When other companies run into these problems, do you think they are potentially cutting corners in the validation, or do you get to a point of good enough and then?
Obviously, I cannot speak for other companies.
Right.
What I would say is that for us, there would have been two easy bailout options, so to say. One would be to say, okay, we give a 6-year warranty. If the fan survives 6 years, that's good enough. We don't care if it survives 10 years, but this is not how we work.
Right.
And the other bailout option would have been to say, okay, why do we need to go for such a small tip clearance?
Sure.
Let's go up by, let's say, 0.2 of a millimeter.
So we talked about that, but then you're sacrificing performance.
Yes, exactly. It seems like a minute increase in clearance, but by our measurements, this would have increased the free flow noise levels by roughly 2 dBA, and it would have reduced airflow through radiators by about 10%. So this is a significant performance penalty.
Right.
And obviously, neither of the two options were attractive to us.
Yeah. So Noctua pushed forward, and you got into. You got into material selection ultimately.
Yes, we had to go back to the material selection drawing board.
Let me tell him really quick. 不好意思，需要大概10个反装，可以吗？10分钟。10个。10分钟。对。对。很感谢，谢。Okay. So materials.
Yes.
I told him 10 minutes, by the way. So materials.
I don't think they like.
We had to go back to the material selection drawing board because after we solved the issue with the cooling water, which was easy to solve but difficult to figure out, the second MVT passed, thankfully, but we ran into an issue with the long-term thermal creep evaluation.
Okay.
Due to the pressure that's being applied onto the fan from radiator screws that are tightened very hard or from fan clips. We have a little illustration here that shows the stress that's being put on the fan from the fan clips, the current ones that pull on the top holes and basically pull the fan down, warp it this way, and then the sides go in and we fall underneath the clearance limits. So that was the issue we sadly discovered in the long-term thermal creep evaluation. So we had to reconsider our material selection choice. Originally, our intention was to use a ABS-PVD combination for the frame, same as for the A12X25. The corrective actual we're envisaging now is that we actually also use LCP for the frame, not just for the impeller.
Right.
Because it gives us much better rigidity, and that's how we hope to get that problem fixed.
And I think it's worth answering the question preemptively for people of, well, why didn't you just start with LCP? And the answer is
the answer is very simple, because it's crazy expensive, and it's going to make a fan that would already have been an expensive fan even more expensive.
Right.
So,
but you are going for best fan, so I guess
the other two options are simply not options we would choose at Noctua. So we rather have the best possible fan and have it very expensive than cutting corners either on longevity or on performance.
Right, and I think the longevity point is an important one, because performance can be shown in testing. Longevity you really can't see in testing without just long-term use. So.
That's definitely the case, but it is literally heartwarming to us when customers approach us telling us that they are still running fans they bought in 2006.
Right.
And this is something we want to keep seeing with every Noctua fan, and not having to tell customers, oh, sorry, your fan failed 2 years after warranty.
Right, that's how it is, yeah. And I do think that's admirable, where, so ultimately, you look at what a company is trying to do, and Noctua very clearly has always, at least in my experience covering it, positioned itself as sort of the quality and engineering first. principles.
Absolutely.
And a lot of companies make cheap fans or just fans that maybe don't go through as many design iterations. So when you look at what makes a company special, Noctua has chosen this as what makes Noctua special. So this is supposed to be nearing finality at this point.
Yes. Now new MVT and long-term thermal creep evaluations are running.
Nice.
I'm keeping my fingers crossed. If everything goes well, I hope that we should be able to launch mass production towards the end of the year. And that should enable us to have the fan on the market within Q1 next year.
Nice. So hopefully a new killer fan coming out from Noctua sometime around Q1 or so next year, along with coolers that we talked about. And thank you so much for the detailed walkthrough.
My pleasure. Thank you very much for visiting.
Absolutely. And we will see you all in the next one.
Bye-bye.